Good morning, students. Today we are going to start our next topic, that is vapor pressure. Last time we have discussed about the evaporation. Now we are going to discuss vapor pressure. Vapor pressure is basically that pressure which is exerted by the vapors of liquid at equilibrium with the liquid. If there is a liquid in a container, that liquid molecules, due to the increase of their kinetic energy, escape from the surface of the liquid and escape upward, move upward. When these vapors of the liquid exert pressure on the surface of the liquid, whose vapors are these? This is called as the vapor pressure. The important point is at a particular temperature. Different liquids having a different particular temperature on which they produce vapors. Vapor pressure is basically that in which the rate of vaporization is equals to the rate of condensation. Liquid vaporize, convert into vapors, and vapors condense back into liquid by condensation. When these two process, the vaporization and the condensation process, the rate of these two processes is equal, then we define that is the vapor pressure of that liquid. For example, container is open. There is no lid, there is no cover on the container. The liquid molecule, due to the increase of their average kinetic energy, they escape the surface of the liquid and move upward. Because of the open system, because of the open container, these liquid molecules mix with the air that is present in the surrounding. So these vapors mix with the surrounding, mix with the air of the surrounding. But instead of this, if the container is closed, if the system is closed, there is lid on the container is closed with some cover with some lid. In this case, when at a particular temperature, when the liquid molecule convert into vapor, escape the surface of the liquid, they will move upward. And as we know, the system, the container is closed. So these vapors will condense back, will again change into liquid. When these vapors again apply pressure on the liquid surface, again exert pressure on the liquid surface, this is called the vapor pressure of this liquid which we take in this container. And the important point is vapor pressure is explained when the rate of vaporization, the conversion of liquid into vapors, and the rate of condensation, the conversion of a gas or the vapors into the liquid is equal. Then we define that it is the vapor pressure of the liquid, of the specific liquid. Liquid may be alcohol, liquid may be ether, liquid may be water. So any kind of liquid you can take. But the one way you can explain the vapor pressure of that liquid is when the rate of the vaporization is equal to the rate of condensation. So when the number of molecules of liquid evaporate, convert into vapors, is equal to the rate of condensation of the condensation of those molecules is equal to the number of the molecules that are coming back, that are condensing. When these two rates, the evaporation or the condensation rate, the number of molecules are same, then the state is dynamic equilibrium, and we say this is the vapor pressure of that liquid. Dynamic is related to the movement. The equilibrium state, the balance state, which comes due to the movement, due to the motion. This is called as the dynamic equilibrium. So both the states are in movement. Here you can see the molecules of the liquid are moving upward, the vaporizing, this evaporating, and the container is closed. Due to that closed container, these molecules coming back, these vapors applying pressure on the liquid going downward again. So when this rate, the evaporation rate, the movement of vapor, and the condensation, the movement of molecules downward is equal, this is the dynamic equilibrium state, and at this point we explain this is the vapor pressure of that specific liquid which we take in this container. So vapor pressure of a liquid depends upon the following factors, as vaporization depend on the different factors, temperature, intermolecular force, surface area. In this way, there are some factors which affects the vapor pressure of the liquid, that how much vapor pressure of specific liquid having and how it is affected by the nature, by the size, by the temperature. So let's discuss. There are three main factors of vapor pressure. By these three factors, the vapor pressure of a liquid is affected. First is nature of liquid. Nature of liquid. Vapor pressure basically depends upon the nature of the liquid. If the liquid is polar in nature, polars mean having poles. Having opposite charges, having positive and a negative poles. So when the liquid is polar, having poles, having charges, then the vapor pressure of those liquid is very low, because the opposite poles, they having a very strong interaction, they having a very strong intermolecular forces. For example, the liquid is HCl, and HCl is polar, as we know, having a partial positive and a partial negative charge, and these partial positive and a partial negative having an interaction with the other molecules. So due to this, all the molecules having a strong intermolecular forces. In the same way, the water having a water molecule having a partial positive and a partial negative charge, hydrogen having a partial positive and oxygen having a partial negative charge. So in this way, all the molecules of the water are interlinked, are connected with each other with the strong intermolecular forces. And as we know, the water having a hydrogen bonding which is intermolecular force, and HCl having a dipole-dipole interaction, which is also a strong but less stronger than hydrogen bonding. So if the strong intermolecular force is present between the molecules due to their polar nature, then those liquid having a low vapor pressure means those liquid will vaporize very slowly. If they are vaporizing very slowly, then they will condense back very slowly. In this way, the rate of vaporization and the rate of condensation is very less. So that's why polar liquids having a very low vapor pressure. The vapors of the polar liquids exert very less pressure because they are not vaporizing as much as the non-polar liquids, as those liquids which do not having a poles. For example, CH4 it's a gas basically. So take take any kind of alcohol, for example C2H5OH ethyl alcohol. So in these kind of molecules, they do not having a poles. They do not having a negative and a positive poles. They do not having strong intermolecular forces. So due to this, due to the non-polar nature of the liquid, those liquid having high vapor pressure because they escape the surface of the liquid easily. if the liquids are in a container, so the liquid molecules do not having a strong intermolecular forces with each other, so they will leave the position, they will leave the other molecules, they will leave the connection with the other molecule and start vaporizing. So in this way, those liquids which do not having a poles escape the surface of the liquid quickly and having a very high, very not very high, but comparatively high vapor pressure. So here you can take the example of water and alcohol. Water having intermolecular forces, that's why having a less vapor pressure than that of alcohol, and alcohol do not having a that much strong intermolecular forces, so that's why having a more vapor pressure than water. Next factor is size of molecules. You can imagine this: if the molecules of the liquid, the size of the molecules of liquid is larger, is big size, then these molecules, the big size molecule, having difficulty to vaporize or to exert pressure on liquid. So in this sense, you can say the small size molecule easily leave their place, easily escape from the surface of the liquid, easily vaporize and easily exert pressure on the liquid. So the small size molecules can easily evaporate than big size molecule. Here you can take the example of hexane. Hexane having six carbons. So this structure is smaller than decane. Decane having 10 carbons. Decane having 10 carbons. So the structure of decane is bigger than hexane. Hexane having 6 carbon structure. So due to this larger, the big size of decane, the vapor pressure of decane is less than the vapor pressure of the hexane. So it's very easy that you can say the big size molecule run away with the difficulty as compared to the small size molecule, they run away easily because of a less weight. Next, we having a temperature. If you are increasing the temperature, the rate of vaporization will increase. So if the rate of vaporization increase, the vapor pressure of the vapors on the liquid surface will increase, because when you are increasing the temperature, when you are elevating the temperature, the kinetic energy of the molecules increases. Kinetic energy means they start moving randomly. The energy that is due to the motion. So their kinetic energy increase due to the temperature. If you are giving temperature to the liquid molecule, they start movement. Due to that movement, they easily escape the surface of the liquid and convert into vapors. So when they leave the surface of the liquid due to the temperature, they convert into vapors and these vapors exert pressure. So these three factors are for vapor pressure. Here you can see this table on different temperature, the vapor pressure of water. At 0 degrees Celsius, the vapor pressure of water in mmHg is 4.58. At 20 degrees Celsius, it's 17.5. And on different temperature, the vapor pressure of water is mentioned in this table, the table 5.1. Next, we having a topic that is boiling point. In our daily routine, we use this term boil, the milk is boiled, water is boiling. So what is the boiling point? What is boiling point? Now we are going to discuss this, that what is the boiling point. As we know, when we are providing heat to the liquid molecules gain energy. The liquid molecules gain energy due to the temperature that we are giving, that the heat that we are providing. So liquid molecule gain energy and start movement. Due to that movement, their average kinetic energy will increase. So if their average kinetic energy will increase, they will overcome the intermolecular forces. The molecules, for example, the water molecules having intermolecular forces. Each water molecule is connected with the other water molecule. So when we are providing heat, then these intermolecular forces are weakened. Due to this heat, due to the temperature, due to the increase of the average kinetic energy, the intermolecular forces will be weaker and the molecule separate with each other, separate from each other. Due to that separation, they will evaporate, they will vaporize. So when they will vaporize, what will happen? Due to that vaporization, the vapor pressure increase, as we have discussed previously. If the temperature is more, the vapor pressure will be more. If the vapor pressure is increased, then that liquid, the vapor of that liquid must have to match the atmospheric pressure, must have to be equal to the atmospheric pressure. We are providing heat to the liquids. For example, I'm taking water in a container and I place it on a stove, providing heat. And in this container, there's a water. So water molecule start moving due to the increase of the temperature, their average kinetic energy will increase. Due to the increase of that average kinetic energy, the intermolecular force between these molecules will be weakened, and the molecules separate out. The molecules break the intermolecular force and try to escape. So they will start vaporization. They will convert into vapors. They will evaporate. So when they will evaporate, the more the evaporation, the more will be the vapor pressure. The more the vapors form, then the more they exert the pressure on the liquid. So there is an increase of vapor pressure when you are increasing the temperature, as we have discussed previously. When this vapor pressure is equal to the atmospheric pressure, atmosphere having a gases, atmosphere having a air, and air having some pressure, as we know, our normal atmospheric pressure is 1 atm. Standard atmospheric pressure is 1 atm, that is equals to 760 torr. And this 760 torr is equals to 760 mmHg, millimeter of mercury. So when the vapor pressure of the liquid, when the vapor pressure of the liquid is equal to the atmospheric pressure, when the vapor pressure of the liquid, when the vapors of the liquid are exerting some pressure that is equal to the atmosphere's pressure, then the point is called as boiling point. It's very simple. Try to understand this. Liquid molecules are converting into vapors and moving upward, vaporizing. These vapors having some pressure. When this vapor's pressure becomes equal to the external pressure, the atmospheric pressure, the pressure of the air, when these two pressures are equal with each other at a given temperature, at a particular temperature, at a specific temperature, then this point is called as a boiling point. Water boils when its vapors, pressure of the vapors becomes equal to the atmospheric pressure, when water start boiling. And as we know, the boiling point of the water is 100 degrees Celsius. So it means at 100 degrees Celsius, the vapors of the liquid becomes equals to the vapors of the external pressure. It's very simple. 100 degrees Celsius is that temperature on which the vapor pressure of the water is equal to the atmospheric pressure. That's why 100 degrees Celsius is the boiling point of the water. On the other hand, ether having 34.6 degree Celsius boiling point. It means at 34.6 degrees Celsius, the vapor pressure of ether becomes equal to the atmospheric pressure. That's why ether having a 34.6 boiling point. Alcohol having 78 degrees Celsius boiling point. It means the vapor pressure of alcohol becomes equal to the atmospheric pressure at 78 degree Celsius. So when the vapor pressure of the liquid becomes equal to the atmospheric pressure, this is called as the boiling point at a particular temperature. Here you can see the definition of boiling point. Next, see this figure, see this graph. We have taken temperature on x-axis, vapor pressure in mm of Hg at y-axis. 760 is atmospheric pressure. As I told you, 760 mmHg or 760 torr is atmospheric pressure at a sea level. We are on the sea level. When we are moving at altitude or on a higher places, then this vapor pressure of the atmosphere is, then this atmospheric pressure is different. But we are at a sea level, so at a sea level, the vapor pressure of atmosphere, the external vapor pressure, the atmospheric pressure is equals to 760 mmHg or 760 torr or 1 atm. These all are equal in different units. So, for example, initially ether having 0 degree Celsius temperature. Initially here ether having 0 degree Celsius temperature. As slowly for example its vapor pressure is very less, not equal to 760. When we are increasing the temperature, here you can see the temperature is increased from 0 degree to little bit more. For example, it's 25. For take it as a 25 or 30. You can just roughly take the idea from this graph. Okay, so if this temperature is increased from 0 degree Celsius, here you can see the increase of the temperature. It's 34.6 degrees Celsius increase. So slowly and gradually the temperature is increased 20, 30, 34.6 degrees Celsius. When the temperature reaches at 34.6 degrees Celsius, at that point the vapor pressure of ether becomes equal to the atmospheric pressure. And at that point ether start boiling. And this point is the boiling point of ether. Next, C for alcohol. Initially, alcohol having very less vapor pressure. Here you can see. And the temperature is 0 degrees Celsius. When we are increasing the temperature, slowly and gradually 40 degrees, 60 degrees, 70 degrees, 78 degrees Celsius is the temperature at which vapor pressure of liquid becomes equal to the atmospheric pressure. And at that point, alcohol start boiling. Water having 0 vapor pressure at 0 degree Celsius temperature. When we are increasing temperature, slowly the temperature will increase and reach at 100 degrees Celsius. And this 100 degrees Celsius is the temperature at which the vapor pressure of this water becomes equal to the atmospheric pressure, equal to 760 mmHg. So at that point, water starts boiling. So by this curve, you can understand that boiling starts when vapor pressure of liquid becomes equal to the atmospheric pressure. In the same way, like evaporation, vapor pressure, boiling point having some factors which affect on the boiling point. So let's discuss one by one. Nature of liquid. In the same way, vapor pressure is affected for polar and non-polar. Polar liquids having high boiling point because at high temperature, polar liquids vaporize. And at high boiling point, polar liquids vaporize and the vapor pressure of these liquid becomes equal to atmospheric pressure at high boiling point. Because polar nature, because of polarity, because of positive and a negative poles, they having a strong intermolecular forces. So that's why they need high energy to break the intermolecular force and escape from the surface of the liquid. So that's why polar liquids having high boiling point. That's why water having 100 degrees Celsius boiling point and alcohol having 78 degrees Celsius boiling point, because water having intermolecular force, because water having polar nature. Next, we having intermolecular force. Stronger the intermolecular force, higher will be the boiling point. It's very simple. If the strong bonding is present, if the strong intermolecular force is present between the molecules, then you have to provide the high temperature to break these forces, to break these bonds. So that's why if the strong intermolecular force, then the boiling point will be higher. Water having a strong intermolecular force, so that's why water having a high boiling point as compared to alcohol, as compared to ether having 34.6 degree Celsius boiling point, so it's very low. Next, we having external pressure. Boiling point is also affected by the external pressure. If the external pressure is changed, the boiling point of liquid will change. Water having a boiling point that is 100 degrees Celsius at the sea level, but at altitude or at a different places, water do not have a 100 degrees Celsius boiling point. If you go on places that are not at sea level, that are at height, so on those places the boiling point of liquid water becomes less than 100 degrees Celsius, lower than 100 degrees Celsius, because of the change in external pressure. If you change the external pressure, the boiling point will change. The pressure cooker that we use in our home is based on this concept. In pressure cooker, if you are placing any kind of meat to boil, and take a less amount of water, you no need to take very large amount of water. In that small amount of water, all the meat is properly cooked or boiled. Because when you are sealing the container, tightly closing the container, then at less temperature, vapor pressure of liquid becomes equal to the atmospheric pressure. So the water which usually having 100 degrees Celsius when container is open is less when you are taking water in a pressure cooker. It becomes less than 100 degrees Celsius or greater than 100 degrees Celsius. Your water will not boil at 100 degrees Celsius. It will be boiled on more than 100 degrees Celsius. For example, 102 degree or 105, 120 degree. So the boiling point of water will increase due to the increase of vapor pressure. To meet the external vapor pressure, because you are tightly closing the container, to meet the external vapor pressure, water need a very high amount of energy to be boiled. So that's why in a pressure cooker, water do not boil quickly, do not boil at 100 degrees Celsius. It need a very large amount of energy to boil. So that's why your meat is cooked in a very less time. and water remains in a container, not quickly evaporate, not quickly vaporize. And pressure cooker also having a one thing, that is condensation. So all the vapors again condensing back into a liquid. So pressure cooker is a very good example to understand the vapor pressure, the boiling points of a liquid. This is all about today's topic. So learn these two topics. We will start our next topic in our next class.